We are on lesson 23, chapter 4, trigonomic functions, radian and degree measure. We're going to break this into two parts, so we'll call this part 1. What we're going to work on today is describing angles using radian measure, using degree measure, and convert between the degrees in radians. The next part of it, we're going to use angles to model and solve real-life problems in part 2. So, looking over here, the definition of an angle is determined by rotating a ray about its endpoint. The starting position of the ray is called the initial side of the angle, and the position after the rotation is called the terminal side. All right, so down here we have an initial side for the angle and we have a terminal side. So after we take this line and we sweep it around, we have an angle. The endpoint of the ray is called the vertex. So here the vertex, we put it on a coordinate plane, so the vertex is at 0, 0. The perception of an angle fits a coordinate system in which the origin is the vertex and the initial side coincides with the positive x-axis. Such an angle is in standard position. So if your angle is right here, if it has for the one side the positive x-axis, it's called standard position. Positive angles are generated by counterclockwise rotation and negative angles are by a clockwise rotation. And some people always ask, why is that? Well, one explanation for it is if you number the quadrants, quadrant 1, 2, 3, 4, if you follow the quadrants 1, 2, 3, 4, it's going counterclockwise against the clock, backwards in time. If you go the other way, that's negative. So even though you'd think you'd go clockwise and that'd be positive, nope, you're going to follow the quadrants, and that is what makes it positive. So going the other way is negative. All right, angles are labeled with Greek letters such as alpha, beta, and theta, as well as uppercase letters such as A, B, and C. All right, so looking here, talking about the angle that we do have here, this angle looks like it's about 135 degrees because we went 90 degrees. This is 90 degrees. We went from 0 through 90, and if you go another 90 degrees over to 180, you've gone halfway through this 90-degree angle, which would be 45 degrees. So we've gone 90 plus 45 more, so this whole angle would be 135 degrees. Looking at this angle here, they wanted us to go negative on it, going clockwise. So going clockwise, again, starting, this is 0, and if we're going backwards, again, we went about halfway through that quadrant of 90 degrees, and half of 90 is 45. So this would be a negative 45-degree angle. All right, here's a rule for converting between degrees and radians. To convert between degrees and radians, multiply by pi over 180. To convert from radians to degrees, multiply radians by 180 over pi. And pi radians equals 180 degrees. Note I didn't star that. I started back here, standard position, and positive angles go counterclockwise, negative ones go clockwise. I didn't bother starring this because honestly, it's just going to make sense and it's going to go okay, but make sure you memorize that. All right, we officially are looking at a unit circle, which you might have seen before in calculus last year. But looking at the unit circle in degrees, again, it starts at 0 degrees. When you make a full circle, you've gone 360 degrees. If you've gone halfway around, you've made a 180. So if you make a 360, you turn all the way around. Someone says you need to make a 360 or turn around your attitude 360 degrees. You're totally turning it around. All right, and if you go halfway over, you've gone 90 degrees. That's a right angle. And if you go half of that, you've gone 45 degrees. And then the other popular angles on the unit circle are 30 degrees and 60 degrees. So if you go, and they talk about it in terms of how far away it is from the x-axis. So going 30 degrees that way, going up 30, that takes you to 150, going backwards, or going back 45 degrees takes you to 135 degrees. Or if you subtract 60 from it, that takes you to 120 degrees. So this technically is a 60-degree angle, but that 60-degree angle is not in standard position. This 60-degree angle is in standard position. So this angle down here is also a 60-degree angle. 180 plus 60 takes you to 240. So technically 240 degrees is a 60-degree angle also. And if you go 180 plus 45, you get to 225. Again, that's a 45-degree angle, just like 135 was 45, and 45 degrees is 45. Going down 30 degrees takes you to 210. Going down 60 degrees, like I said, takes you to 240. And then 3/4 the way around, or plus 90 degrees, is 270. And then plus 45 more takes you to 315. And then if you add 30, well, no, if you add 30, you get you 300, and you add 60 to that, it takes you to 330. All right, so let's talk about radian degrees. So, like I was showing you on the front page, to make life complicated, they changed things to Greek letters and stuff. So 180 degrees is pi. So if you make a full circle, you've got another 180 degrees, or 2 pi's. So if you've gone from here to here, you haven't gone all the way to pi, but you've gone halfway around to pi. So you've done half a pi, or pi over 2, 1/2 pi. If you've gone between 0 and pi over 2, you've done half of that. Half of a half is a 1/4. So you've gone 1/4 pi, or pi over 4. And then if you go between pi and 2 pi, you've gone 1.5 pi's, you've gone a pi plus half a pi more. So you've gone 3 pi over 2. And then another way that's easy to think about it, if you don't want to like reason out how far you've gone around the unit circle, like you went halfway around, you went 1 pi around, you went 1.5 pi's around. If you don't want to think it out like that, another thing you can do is convert the angles to radians. Let me show you how to do that. So if you have 60 degrees, changing that to radians, what you want to do is you want to cancel out the degrees. And so you want to use the conversion. Pi is 180s. Just like when you change feet to inches or inches to feet, you multiply by 12 over 1, or just that's your conversion on it. So on this, the conversion is pi equals 180. So what you're doing here is 60 over 180 is what it is. And I'm just going to go ahead and reduce that. If you have 60 over 180 pi's, the zeros are gone. And then you have 6 divides in the 18th 3 times, so that makes pi over 3. So 60 degrees is pi over 3. And then 30 degrees. So doing it again here. So if we had 30 and we want to change that into pi's, cancel the 0 out, and 3 goes in the 18th 6 times, so that makes that pi over 6. So trying it again here. Let's change 210. If we change 210 over into pi's, again, we don't want it in degrees, we want it in pi's. So cancel out the zeros, and you got 21 over 18. And those both divide by 3. And so when you divide them both by 3, you get 7 over 6 pi. So this one is 7 pi over 6. And you can do that for all of them around the whole entire unit circle. So, and you're going to want to learn how to do that, and you're going to want to memorize them all. So 120 degrees is 2/3 pi. And 135 degrees is 3/4 pi. We'll do the 45-degree angles first. So we got pi over 4, because we have 1/4 of the whole, 1/4 of the pi. And then we had half of the pi, and then over here we have 3/4 of the pi. And then when we go down here, we have 1 pi plus 1/4 more. So we have 1 1/4, or 5/4 pi. And then over here, we have pi plus, we have 3/4 more of the pi. So we have 1 and 3/4. 1 and 3/4 is 7/4. So 7/4 pi. And again, all of those are 45-degree angles, but they're not in standard position. But they're all 45-degree angles. Again, you think about the angles and how far they are away from the x-axis, and that tells you how big the angles are. And we're going to talk about that more. I'm just trying to get it in your mind here right now, trying to wrap it around. If you just change the 240 though, we'll do it again here. If you want to change 240 and not think about it, so 240 degrees, got 180 here and then pi. So you got cancel out the zeros, and then 24 and 18 both divide by 6. And then you end up with 4 pi over 3. And then 300 degrees is 5 pi over 3. And 330 degrees is 11 pi over 6. Okay, I know we kind of overachieved, but it'll come in handy. We'll talk about it more. Okay, next up, we're trying to determine the quadrant in which each angle lies. So we got 5 pi over 6. Again, this is 0 and this is 1 pi. This is not even a full 1. That's less than the number 1. 5/6 is less than 1. So we don't even have a full pi, but at the same time, it's more than the number 1/2. 1/2 pi, or pi over 2. So that one is in quadrant 2. And down here then, negative 5 pi over 3, that's more than 1. That is negative 1 and 2/3 pi. And since you're negative, you're going backwards. So there's 1 pi. Now we need to go 2/3 more. And again, that's more than a half. So that's going to take you over here to quadrant 1. Okay, on the next page, they want us to sketch each angle in standard position. All right, so we got 11 pi over 6. So 11 pi over 6, that again, that's over 1 pi. It is 1 and 5/6 pi. So you're going to go, again, that's 0. You have to go 1 pi, and it's over halfway over, and then 5/6 is going to take you up to here. Let's change it to, what do we want to change it to? Let's change it to degrees for fun. And the way you change it to degrees is pi is 180. So I'll do it out long, and then I'll make it quicker. So we have 11 pi over 6. So we want to get rid of the pi. Again, the conversion to do it is pi is 180 degrees. So cancel out the pi's, and then I'm going to 6 goes into 180 30 times, and the 30 times 11 is 330 degrees. So even a better picture than that, because I made that look almost like it was 45. So for letter A, honestly, so it's not quite 45 degrees there. It's 30 degrees down. It's at 330, which from 360 is 30 down. So overall, you probably want to go right about there with it. So that would be 11 pi over 6. And then, a quicker way to do it is, honestly, if you want to get rid of the pi, if there's a pi in it, just put the number 180 in it. So that means 11 times 180 over 6, because you're canceling the pi out. So 6 goes in the 180 30 times, and 30 times 11 is 330 degrees. All right, let's do that on the next one. So let's put the 180 in there. So then 3 goes 180 60 times, and 60 times 2 is 120. So on letter B, we want to draw an angle that is negative 120 degrees. So starting from 0, going backwards, negative 90, and then we need to go 30 more than that. Again, that's 45 degrees, so it's going to be somewhere a little bit less than that. So all the way around to there would be negative 2 pi over 3. That would be a picture of it in standard position, because I said to do it in standard position. So that means that the initial side is the positive x-axis. All right. So moving on here. They would like us to find coterminal angles. Coterminal means it lands in the same place. So currently, this is the angle, 7 pi over 6. They want two coterminal angles, one that's positive, one that's negative. So to get another positive one, just loop back around another 2 pi. So you're going to go 7 pi over 6 plus 2 pi's. We'll come back to it. And then if you want a negative one, what you want to do is you want to go backwards. So instead of going forward with it, what we want to do is go backwards with that angle. And so we want to go around backwards from it. So what we want to do is subtract 2 pi from it. So 7 pi over 6 minus 2 pi. So, and they said that, well, they said we could use, they didn't say we couldn't use a calculator, but I don't know, let's not use one. So remember when you combine fractions, we're combining 7 over 6 plus 2. So the common denominator is 6. So 7 pi over 6 plus 12 pi over 6. Because I need to multiply those both by the number 6. So altogether we got 19 pi's over 6. Remember when you add fractions, you're just adding the top numbers, 7 plus 12. Okay, and then on the next one, again, it's common denominator, so it made it 12 pi over 6. So we got 7 pi over 6 minus 12 pi over 6. 7 minus 12 is negative 5 pi over 6. All right, so those would be the two angles. And let me show you how you can cheat with your calculator. So on the first one, it was 7 over 6. So just do 7 divided by 6 plus 2. And remember, you hit math, enter, enter, and you get 19 over 6. And the other one was 7 over 6 minus 2. And again, hit math, enter, enter, and you'll get the negative 5, 6 pi. Okay, it'd be the same thing on the next one. Same idea. Okay, on the next page, it's the same thing again. They want two coterminal angles. So just like on the last page, how we added 2 pi and we subtracted 2 pi, it's the same thing on here. So it was 114 degrees. So we want to add 360 degrees. So we're not adding 2 pi, since it's in degrees, you're adding degrees. And then you're going to also subtract 360, add it and subtract it. So when you add it to it, you get you up to 474. When you subtract it, you get negative 246. This one's kind of fun. We'll do that one. So they want a positive and a negative. So negative 390 plus 360. Notice that's still going to be negative. So what you do is just add another 360 again. And that'll get you to positive 330 degrees. And then the other one, if we just want to add one 360, that would take us to negative 30. So then we have a coterminal negative angle and a coterminal positive angle. So they all land at the same place. Okay, so we talked about this already, but we want to change this from degrees to radians. Again, what you want to do to get rid of that degrees is divide by degrees and multiply by pi. Leave the pi out of it. All you're going to do is smack the pi on it when you're done. So cancel out the zeros, and then 27 over 18 both divide by 9. So that makes negative 3 over 2, and then smack the pi on it. Notice they said don't use a calculator. So you need to be able to figure this out without a calculator. I think I'll have you do like a little quiz without it. Okay, same thing here. So we got 144 degrees, and we don't want degrees. We want it in radians. So again, leave the pi out of it. So you got 144 over 180. So divide it by 2, and then divide again, and you end up, after you finish reducing it, you'll end up with 4 fifths pi. Okay, so this we've done. They want you now to convert radians to degrees. So like I told you, you got negative 15 pi over 6. We don't want the pi. We want to cancel out the pi. We want degrees, and the conversion again is pi is 180. And so 6 then goes in 180 is 30 times, and then 3 times 15 is 45. Smack the 0 on it. So it's negative 450 degrees. The next one says we can use a calculator, which is awesome because that one's a little bit of work. So putting the 180 degrees in there, 5 times 180 and then divide by 11 on your calculator, you'll get 81.82 degrees. Okay, on the next one, they want us to convert this from degrees to radians. It's the same idea. It's 83.7 degrees. Again, we don't want degrees. We want it in radians, so the pi. Again, leave pi out of it. Well, they want us to go all the way to radians. All right, we'll do it all the way to radians. But, so 83.7 divided by 180. If you leave pi out of it, it makes it 0.465 pi. All right, they want it totally in radians, so that means that you multiply it by pi. And so that makes it 1.46 radians. So that's the answer. That's totally in radians. Okay, on the next page, we want to change this to degree form. What you do to do this is divide that by, because it's in degree, minutes, seconds right now. So the degrees are okay. If you want to change this back to a decimal, remember there's 60 minutes in an hour, so that makes it negative, leave the negative out of it. Negative 408 plus 16 over 60. And then in the seconds, there's 3,600 seconds in an hour. And if you do all that math on it, you get negative 408.274. And if you want to use your calculator for it, so 408, let's see, we have degrees. What you do is you go to angle, which is above the word apps, second, and then apps. And there's angle. And then they had 16, so 16, and again go to the angle, which is above apps, and there's the minutes. And then last of all, they said 25. Now the seconds, this one's evil, it's down here above the plus sign. So you have to use the alpha key to get to it. So second, alpha, and hit enter, and it gives you the answer I just got of 0.274. All right, going backwards to change it to degree, minute, second form, all you have to do is multiply the decimal by 60. So 490, just do the decimal, 0.75 times 60, and you get 45. So it's 490 degrees in 45 minutes. Or your calculator will do it for you, 490.25. Go to that apps, the angles again. Go down to choice 4, degrees, minute, second. Hit enter, bam, it's done. 490 degrees in 15 minutes. I'm sorry I went fast at the end. We're running out of time. All right, I'll see you in class.